All right, today we're going to talk about conservation of energy. This is somewhat of a lie. Einstein comes along a little later and throws this out. But for now, we are going to say that the energy of the universe must be conserved. You've heard this before, probably in chemistry, where we talk about the fact that mass must be conserved. If I have a marker right here, I can grind this up into a million little pieces, but I can't just make it disappear. Whatever this is made out of, the atoms that are in here, they have to go somewhere. Energy is the same way. It's a property of matter. We can't actually hold it in our hands like we can a marker, but there's something about this energy that must be maintained. So you cannot create new energy. All the energy in the universe has already been created. You can't get rid of energy just because you don't want it any longer. Your only option is to move it around from one place to another by doing work. Okay, those are your only options. Okay, so now I'm going to introduce what I call LOL graphs. Okay, they're bar graphs in which we are going to look at the they're bar graphs in which we're going to look at the potential energy due to gravity, the kinetic energy of an object, and its spring energy or its elastic energy that an object has in the beginning and at the end of a situation. So we'll call this like beginning and ending. Okay, so the circle represents our system, and a system is any set of objects, and you get to define the system in any way that you want. But I'm going to caution you that you need to be pretty wise about how you choose your system, because the problem will become either simpler or more complex depending on what you put in there. So I'm going to start off. I've got a box that is currently floating above the ground, above the earth, and I'm going to draw my system. I drew a dotted line here that includes both the earth and the box. So my system is box plus earth. That's my system. And right now, my system contains potential energy because the earth is pulling on the box and the earth's pull is inside the system, right? So there's a force on the earth, like I had to do something in order to get that box up there. And in order to do that, I had to push with my hand over a distance. So I did work on the box, and that work is now stored in there as energy. Mr. Garska likes to think about this in terms of as I separate the box from the earth, a gravitational field appears between them, and energy is stored in that field. However you want to look at it is fine. I'm going to say that we have some amount of gravitational potential energy. You'll note that there is zero scale on this thing because I really don't care what the numbers are. I just want to know that I have some amount that I'm representing by a bar here. I have no kinetic energy because my box is just sitting there, and there's no spring in this problem anywhere, so I don't have any spring energy. Now I'm going to come back sometime later, and the box is going to have fallen to a new position here, just before it touches the ground. So the box has come down. Well, wait a minute, do I still have the potential energy of the box? Is the box still above the surface of the earth? And the answer is no. So my potential energy here is much lower. I'm going to just draw it like so to say that there's a tiny bit left, but for the most part it's gone. Well, where did that energy go if the energy of the universe must be conserved? Well, when I let go of this box, it is now falling. It has a speed, and I'm going to tell you that all of that energy became kinetic. Okay, that I've transferred my energy in my system from being stored as a potential energy because of the way that the objects are separated, okay, to a kinetic energy because now one of my objects is moving. Actually, that's kind of a lie. Both of my objects are moving. The Earth is rising up and the object is squishing down. So my system will have a kinetic energy because both objects are moving. Okay, let's take the same exact situation again, but I want to define my system differently. So now my system is being defined by the box only. The Earth is no longer part of it. So if the Earth is not part of my system, then I just have to look at the box by itself. Does the box by itself have any potential energy? Well, if all you're doing is looking at this box, where is it? I don't know. I have no idea. It's just floating in space. So does it have a potential energy? And the answer is no. It's the only object in my system. So it's not separated from anything else. It is the only object in the system. So my object has zero potential energy. It has no kinetic energy because it's just sitting there at the moment. And there's no spring, so I don't care about the spring. But if I check back on this object a little bit later, it's now almost at the ground and it is moving really fast, right? So it clearly has a kinetic energy at the end. There's still no other object in my system. So I can't have any potential energy, right? It's just a box. The box is now closer to this thing called Earth. But the Earth is not part of my system, so I don't have any potential energy like that. So where did this energy come from? It looks like I started off with no energy, and now I've got this some amount of kinetic energy that came from somewhere. So what's going on here is that the Earth is exerting a force on that object. And the force is coming from outside of my system because it's the Earth that's doing that. And I'm operating over some distance h, like whatever this distance is here, we're calling that h. So now I've got a force and a distance, so the Earth is doing work, and a work equal to the mass times the gravity times the height. So the reason that my object has kinetic energy at the end there is because the Earth is doing work. Okay, the Earth is doing work on my system, pushing energy in. Okay, now this is a positive amount of work. Okay, so work is positive in this case, meaning that the work is entering the system. So energy enters. Now let's look at this. My force is downward and my distance is downward. So force and distance, both in the same direction, give me a positive amount of work. Okay, so we get positive amount of work. Energy is entering my system. So far, so good. Let's take a look at another example here. All right, new system. I've got my mass that's going to begin up in the air again. So somebody's lifted it up and left it there. I've got this spring. Look at this beautiful artistry, right? And the Earth. And in case you can't see my dotted line here, everything, all three objects, the Earth, the spring, and the mass, are inside my system. So box, spring, and Earth are all members of my system. So to begin with, the Earth is pulling on the mass inside the system. So somehow there's been energy stored here where the mass and the earth are separated. So I have a potential energy. So I'm going to show that potential energy. Nothing is moving at this point, so my kinetic energy is 0. Nothing is stored in the spring. The spring is just sitting there. It's in its natural springy state, whatever that is. So there's no energy of that spring. And now I'm going to let go of the mass. And the mass is going to fall down. I'm going to draw you an after picture. So afterwards, the spring is going to get squished, and my box is going to be here. So clearly, the mass and the earth are now closer together, so they don't have as much stored energy as potential. So let's draw a small potential energy box there. But if we left it at that, then I'd have an issue. Like, where did all that initial potential energy go? I'm not allowed to get rid of it. I have to move it somewhere. Well, the spring is now compressed. And you remember in the last video I said, like, are you afraid of a hammer? No. Are you afraid of a hammer that's like hung over your head? Ooh, that could be something. What about a hammer that I throw at you? Yes. So I could ask the same thing, are you afraid of a spring? And the answer is probably no. But what if I compress that spring and put it really close to your face? Like, if I let go of it, that thing could go flying in there. So there's some energy stored in the spring. So now I have some amount of spring energy that if I added these things together, I would get my original potential energy. Just like so. So then the question is, like, why? Well, the mass, as it comes to rest, is placing a force on the spring downward, and the spring is being compressed downward. So we've got some spring squishage. And if my force and my distance are in the same direction, I now have a positive energy, which is going to be stored in the spring. Okay, let's do this again, but I'm going to change up my system. I'm going to take the spring out of my system. So here is now my system. So the Earth and the mass are part of a system, but the spring is carved out. It's its own thing here, right? So I've got a potential energy because the mass and the Earth are still attracted to each other. They're squishing, so they've got some ability together to cause a change. So I've got potential energy. But then when I get down here, I now have less potential energy. And I've already said, well, isn't there energy in the spring? And well, yes, right? That didn't change. But now the spring is not part of my system. So if the spring is not part of my system, I can't draw it in there. I can't put a box to say, here's what it is. So did I violate the law? And the answer is no, you're not allowed to do that. So where did this potential energy go if it's gone and it's not in the spring and it's not moving, so it can't be kinetic? Well, the box and the Earth are doing work on the spring. So what we have is that the box and the Earth are doing work on the spring, so we're actually losing that work. So work is leaving the system. Okay, so wait, how's that work? So let's take a look at this. Now, we are only interested in the mass because it is the only thing that's part of our system. So what are the forces on this thing? Well, we have got a gravitational force pulling it down, and I've got a force from the spring pushing it up. So there's a force of the spring pushing it upward, but the mass itself is moving downward. So now when I multiply my force times my distance, they're in opposite directions. And so now my work, oops, I should keep the same color. Now my work is going to be negative because my work is exiting the system, or energy is leaving the system. Okay, so whenever my force and my distance are in opposite directions, that means that work is being done on something else and it's leaving the system. Okay, here I have a Tesla battery fully charged, and I'm going to drive this thing around until it dies. So my system is my battery operated Tesla there. And I'm going to look at the system. Let's put my dotted lines around there. So there's my system. Does my system have potential energy? The answer is no, because it's the only object in there. So since the Earth is not part of my system, I can't have any gravitational potential energy because it's basically just a Tesla floating out in space there. It's not moving yet, so it has no kinetic. There's no springs, so obviously my Tesla has no energy. Nah, that's not exactly true. Let's come up with a new one, which we could call potential energy of electrical or some kind of battery potential energy. I'm just going to call it battery energy, electrically stored energy anyway. Now, I'm going to drive this thing and drive this thing, drive this thing. So at some points it has kinetic energy, might have potential energy if it's going up and down hills, but I'm just going to pick up the story again when this thing has been driven to death. And now it's dead on the side of the road, right? So what kind of energy do I have left? I'm parked on the road. The Earth is not part of my system, so I have no potential energy. I'm dead on the side of the road. I have no kinetic energy. There's no spring in here. The battery, dead. That's why I stopped. There's no energy left in there. Oops, I don't think you can see my battery picture any longer. So my battery has no energy. So I went from having battery energy to no energy. Where did all that energy go? Answer, it left the system. So it left the system as what? Right? So it's leaving. So energy leaves as heat due to friction. Really, the only reason that you need a battery is because you need to fight against air friction, you need to fight against friction in the bearings of the car itself, friction in the motors, friction of the tires on the ground. Because remember, the first law says that if I were in a perfectly frictionless environment, if I could get this car moving, it would just continue to move forever at a constant speed. So the reason I need the energy is to fight all those frictions and to turn. Right? That's the only, or to slow down is the only reason I need energy at all. So I'm going to leave here. The energy will go. What if, last thing, what if I included the Earth as part of my system here? Well, I might have a little bit of potential energy because my car is mostly above the ground, but it's mostly above the ground anyway. So that's going to stay the same. My battery energy is still going to go way down. So now what's going on? My energy cannot leave the system because the Earth is part of the system. Where's that energy going to go? So if it's not going anywhere, I would probably need to add even another place over here, and let's call that like heat. And I'd need a heat bar, like so. So the purpose of these diagrams, just to sum up, is that we can get a pictorial view of what kind of energy am I starting with, what kind of energy is ending up somewhere, and then making sure that we don't lose any energy, that we account for it everywhere as it's moving.